Alright guys, welcome back. So let's take a look at how we can load a texture, right? Because our cube looks like fancy, but it's kind of hard to recognize if we don't have texture cues on the cube so we can see like different faces. Okay, so we need to actually get something from the internet. So I'm gonna go find some textures. I'm gonna go search for wood plank texture seamless. Okay, and then I have this one, right? I'm gonna go ahead and download that. Okay, you can find a different texture if you wanted to. So I'm gonna go ahead and save image. Okay, and then I'm gonna save that into somewhere in our source folder, of course. So I'm gonna add a new cookie cutter. Add a new folder here. Okay, call this guy texture. Okay, and then I'm gonna go open folder so I can copy that directory basically, and then save my texture in there. Right, I'm gonna call this guy plank texture. Okay, that's saved, so we have it in there. Even we don't see it, but I can see it in the folder structure. Okay. Alrighty, so we have that. We have that plank texture. Moving on from there, we can actually load that, use a library. Okay, the library is called Stbi Image. Again, we need to go ahead and search for that. Stbi Image. Okay, and then you look for the GitHub link. And this is a header only and one single header file library. So all we have to do is copy everything here. I'm going to click on raw to go to the raw data. I'm going to copy everything. And then here in the source folder, I'm going to go add a new atom and name the atom Stbi image. And then hit add. That's going to add it in there, right? And inside of it, I'm going to paste everything I copied over. To use it, it's going to be fairly simple. All we have to do is scroll to the top and just copy that. Right, just copy that to define it before we include this header. So we're going to go back to main and define that, and then hash include and Stbi image, right? It doesn't like that. Yeah, I guess that's because our source folder, even that's in our project, but it's not in the search folder for headers. So we need to go ahead and go to properties of the project, and in the include directories, let's go to edit. And here we need to define, hey, I want to also read any file that we're requiring, right? Try to find it in this project directory, right? And then src folder, and hit OK, and hit apply, and OK. Right, that should allow us to get this library loaded. And we're going to do that maybe after we have all the shaders in, right? We can go ahead and start loading our image. Okay, so first of all, we need to create a texture, right? That's very similar to our VAO and VBO objects. So onsend int texture, right? Use lower t maybe. Let's use upper t. Okay, all right. So we have the texture, and then we GL generate texture, right? And then let's see, we need to use size, which is 1, and then the address of texture. Okay, and then GL band texture, right? We're gonna band our texture, and then the target will be GL texture 2D, I believe. And then the texture will be our texture, of course. Okay, so now we have our textures, okay, and we need to actually start to use Stbi image to load it. Okay, to do that, we need to call the function Stbi load, right? And we need to specify the file name, which in this case is going to be resources, and then texture, and then the name of the textures, which is let me copy that real quick. Plank.jpg, right? It also will help us to populate the width and height. We can create that, of course. So int width, height, and I believe it does require another thing called the comp, right? So I'm gonna do that. The comp will be basically components, right? What kind of how many components are there? So RGB should be the one we will get. Anyway, so I'm gonna go get width and height. Of course, it has to be passed by our address or pointer, right? and then eventually the components, which is also that. Okay, and then required component, we can specify how many component we're looking for, but I guess we just don't really care. We can type in 0 and it's going to give us as much as it can find. Alrighty, so with that being created, then we can do a oh, actually that will return a data type, which is of the type Stbi UC, right? UC data equals to that, actually a pointer of that. Okay, however, that's actually their own type, so if in the future we want to change this, it's better to not using their defined type. But you can see that's basically a unsend char, so we can change that to unsend char pointer, right? And that's it. That's how you read the data, right? I'm going to check if the data is in there, right? Then we can specify the GL image texture 2D to start populating, right? The target, of course, will be our GL texture 2D, okay? And then the level will be 0, which is the first MIP map we're trying to do. MIP map is basically like when you have an image, right? And you need to read it, but when you're having the model really further away, there's no point of reading the full image, right? You're gonna read like a scaled down version of that image. And that's something we call a MIP map, basically like a collection of maps that's having bigger versions and smaller versions of the same texture. That way it's going to load the proper sized MIP map, so that whenever you're closer or further away, you're loading a appropriate sized texture, so that you're not wasting memory and you're loading it properly. It's showing up nicely. Okay. Width and height, we have those things already. So width and height. Border doesn't really care. That's actually maybe a legacy. I think that's a legacy value there. It doesn't really mean anything now. Format, of course, will GL RGB. Okay, RGB. And then the GL in type, that's gonna be the type we're using, right? We're using characters. So GL, I believe just byte. GL data or something. Actually, I forget that value. This is a really long function. I'm gonna copy that and look for it. Type. Yeah, this is really hard to find. Then maybe you can find it in here. I know it's the byte type, but what kind of a byte is the one I'm looking for? Oops. Data byte or something. Let me see. Unsend byte. Where does this thing go? It's in the GLAD. Then why I'm searching byte doesn't give me anything? That's just weird. It's right in there. It doesn't really search that for me for some reason. Because it's in there, isn't it? That's just weird. Let me copy that and paste that. So search for that byte doesn't like that, huh? That's just fantastic. So I'll close that, and then back here after that, we're gonna go for the actual data. Oh, actually another type. So GL RGB, right? That's the it requires the internal format and format twice, I believe. Oh, let's take a look. This is getting a little bit more confusing. So RGB, after RGB, what do we have? Format is going to be again border. Huh. Let me go back here. So we're doing height and then we're doing border, which is 0. So this one is level 0 internal format. Yeah, we have to define it here. RGB. I'm thinking something feels wrong. So RGB right in here, and then that's 0 for the border, and format again it's GL RGB one more time. One is internal, another one is the actual format for the image. And then enum type. Yeah, that's the thing I got stuck earlier. So unsigned byte, and then that's when we pass in our data. So a very long function with a lot of arguments. This is not uncommon though for complicated game engines like Unreal. You'll see this very often. But Unreal Engine have very good documentations on those things. OpenGL, you sometimes need to search for the meaning of those things. Anyway, so we have the texture here, right? And then we need to go ahead and start loading it into a bunch of actually generate a bunch of mip maps. So GL generate mip maps. Okay, and then GL texture 2D. All right. Alrighty, so that should be the thing we need to do. So we have the texture loaded. Now eventually you want to tell it to not being used anymore by STBI. So we can do STBI image free and then data, and that will be everything we need to do for this to work. Okay. Now of course we need to pass it over to our shaders. Okay. So in this case, right, we need to go ahead and get the UV in first. The UV is already out in here, so we just need to do a in vac2 texture coordinate. All right, so all right, and then we can use it. Let's see where it goes. Okay, so here our color, then we'll have to read from a texture, right? For a texture to read though, you need to pass in something called a sampler 2D, and then you type in your texture coordinate. Okay, that texture 2D or sampler 2D, right, has to be passed in by something we call a uniform. So we do that. So the uniform is basically kind of like a place that we can passing data to any shader right away without passing data around from shader to shader. Not like this one, you have to pass it over from vertex shader, right, to here. Uniform can be just a place to receive data from any shader anywhere right away. So and the data type we're going to use is again sampler 2D. Okay, we can call this guy our texture. Okay, I'm going to use uppercase T though, because this symbol is occupied by that function. Alrighty, so we're basically reading the texture using this texture coordinate. Now of course the texture is not passed in yet, right? To get it passed in, we need to do a GL get uniform location first, right? And then we need to pass in, let's see, program. So our program is, yeah, we have a program, so program, and then the name of the variable name, which is texture, right? The same name we write down in here. So now this will get a location, and that's going to be returning an int, right? So we int texture uniform location will be equal to that, right? Once we have that, and we can pass it in by doing gl uniform 1i, right? That's how we pass in basically sampler 2D, right? And let's see what it takes. Takes the location, which is something we just retrieved here. And second thing is which one texture we're passing in. Actually, texture is a list of textures. So when we're creating texture, I guess we can activate texture and gl texture 0, right? And then everything is based on this texture 0 now, and this one is that texture 0, which is in this case our texture here. All right, that will pass the texture information to this guy, which will be then read by our final color here. So let's go ahead and run this. You can see indeed we're reading the wood texture, right? It's a bit stretched, but at least it's read properly, right? Because we have the correct UV coordinate written down in here, and then we're loading it also, properly using those various functions. All right, so yeah, that's 15 minutes to load a texture. Moving on to the next, we're going to talk about maybe we can rotate the cube, right, so we can see it from not directly head on. Okay, see you guys next time.